Hey everyone, and welcome to this explainer. Today, we're unpacking this absolutely fascinating new research paper called From Understanding to Resonance, a case study of quantum music and embodied science communication. Now, right off the bat, I want to acknowledge the elephant in the room here. Look, when most of us hear the phrase quantum physics, our brains immediately jump to like a giant dusty chalkboard covered in math that's so complex it literally gives you a headache just looking at it, right? It feels distant, it feels super technical, and honestly, for a lot of us, it just feels completely inaccessible, like it's a subject permanently locked behind heavy doors at some elite university. But what if we completely flip the script on how we communicate highly abstract science? What if, instead of just trying to force people to understand it, we actually started trying to make them feel it?
Okay, let's dive into this. I want you to really try and imagine something for a second. Can you feel quantum physics? I mean, normally we encounter these kinds of scientific concepts through textbooks or dense lectures or, maybe a really carefully worded documentary. But this research, it asks us to imagine encountering quantum mechanics directly through our senses. Like, what if you could actually hear a superposition? Or what if you could physically feel quantum entanglement through a shared experience rather than just reading some dry definition on a page? I know, it sounds a bit like science fiction, but as you'll see today, it is a very real and wildly successful new frontier in science communication.
So, traditionally, science communication is heavily what we call explanation-centered. It relies on technical language, it's highly abstract, and frankly, if you don't know the math, well, you're locked out. It creates this massive distance between the expert and the audience. But the researchers behind this paper are proposing a completely different paradigm. They call it a resonance-driven approach. And this model, it's immersive, it's embodied. It essentially uses artistic environments to bridge that gap. Instead of demanding that you compute the science in your head, a resonance-driven approach invites you to just experience it. It's warm and inviting, especially where the traditional approach can feel pretty cold and intimidating.
Now, you might be wondering where all this is coming from. This research isn't just happening in a vacuum. The global backdrop for this study was actually the International Year of Quantum Science and Technology. And during this time, the scientific community sort of had this collective realization about a very specific challenge. They knew they desperately needed to find alternative entry points into these highly abstract fields. They had to find ways to invite the general public into the quantum world without making them, pass a grueling physics exam first. And that specific global initiative set the perfect stage for the incredibly unique experiments we're going to look at today.
To actually test this resonance-driven paradigm in the wild, researchers Kenji Noda, Akira Koga, Stefan Hessler, and Koji Hashimoto decided to analyze two major real-world events. We've got Quantum Fest in Japan and Quantum 100 in Germany. And what's just absolutely brilliant here are the mediums they chose. They didn't use lectures, they didn't use slideshows. They used music, visual art, and physical embodied participation. They took the wildly abstract rules of the quantum realm and literally turned them into immersive artistic experiences. These were designed specifically to act as friendly, alternative entry points for everyday people.
And if you're sitting there wondering whether an artistic approach to physics actually works, well, 4,000. Across these two initiatives, they attracted more than 4,000 participants. I really want to highlight the sheer scale of this engagement because it proves a vital point. These were absolutely not just tiny niche art experiments for a handful of hardcore physics enthusiasts. No, this was a massive, mainstream success. Thousands of everyday people willingly chose to spend their free time engaging with quantum science simply because the invitation was framed through art and music. Talk about a game changer.
Of course, in the science world, you can't just host a fun concert and call it a success without the data to back it up. So to rigorously measure the actual impact of these events, the researchers utilized three concrete data points. They looked at post-event surveys, direct participant comments, and in-depth stakeholder interviews. Basically, they cast a really wide net to capture exactly what these attendees were feeling, what they were thinking, and what they actually retained after walking through these immersive quantum environments. And the data they collected, it allowed them to identify something truly remarkable about how we as human beings actually learn.
Now, what's really interesting about this slide is how they took all of those surveys and interviews and categorized their findings into the academic core of the paper. They call this the 3 dimensions of resonance. And this right here is how they explain exactly why art and music are so incredibly effective at communicating quantum mechanics. We're going to break down each of these 3 dimensions right now so you can see exactly how this paradigm shift operates in the minds of the audience.
All right, the first dimension they identified is sensory immersion and reduced psychological barriers. Let's be honest with ourselves. Most of us immediately build up defensive walls when we're faced with heavy physics. We get intimidated, we think, oh man, I'm just not smart enough for this. but by using an artistic, sensory-rich environment. Think like a dark room filled with quantum-inspired music and trippy visuals. Those psychological barriers just sort of melt away. The intimidation factor literally drops to zero. Because it's art, right? There's zero pressure to get it right, which paradoxically opens the mind up to actually engage with the science.
And that sensory immersion naturally builds right into the second dimension, collective embodied meaning-making. See, when you're at a festival like Quantum Fest or Quantum 100, you aren't sitting all alone at a tiny desk. You're physically participating in a shared experience with a whole crowd of other people. You're feeling the heavy bass of the music, you're seeing the visual art, and you're moving through the physical space together. This physical, collective participation creates a really powerful group connection to the material. People start constructing meaning out of the science together through their bodies and their shared environment. It completely bypasses the need for a traditional boring lecture.
And that leads us right to the third and final dimension, emerging transformative engagement. Honestly, this is where the magic really happens. The researchers found that this resonance isn't just like a temporary high from going to a cool, flashy art show. It actually creates a lasting shift in how the participants interact with and relate to the scientific concepts. By experiencing quantum physics through art, the audience actually develops a persistent curiosity. It completely transforms their relationship with science. The subject goes from being this scary, distant concept to something they suddenly feel a deep, personal connection to.
So the crucial point is how these meaningful relationships with science actually form in the first place. The researchers realized that people can connect deeply with scientific concepts before they achieve conceptual understanding, alongside it, or even beyond it. Think about that for a second. You do not need a math or physics degree as a prerequisite to connect with the wonders of the universe. Resonance-driven communication actually proves that the emotional and sensory connection can, and maybe should, be the very first step in the learning journey.
Ultimately, the paper comes to a very clear conclusion, and I'll quote it here. Resonance-driven approaches can complement explanation-centered science communication. Now, this is absolutely crucial. They aren't saying we should just go out and burn the textbooks or stop explaining the hard facts of physics. Not at all. What they're arguing is that art and resonance brilliantly partner with factual explanations. Art gets people through the door, it drops their defenses, and it sparks their wonder, which creates the absolute perfect foundation for those heavy explanation-centered details to land later on.
Which leaves us with a final, pretty provocative thought to take away from today's explainer. What else could we understand better if we tried to resonate with it first? I mean, if immersive art and music can make something as famously complex and intimidating as quantum physics accessible and engaging for thousands of everyday people, just imagine applying this embodied learning to other massive challenges in our world. Whether it's climate data, artificial intelligence, or complex biology, maybe the secret to truly understanding our world isn't just trying to explain it harder, but actually finding a way to feel it together. Thanks so much for joining me on this explainer, and keep staying curious.